and welcome to today's lesson. Welcome to today's lesson. Before we talk about anything, let's do a quick recap of what we talked about. In our previous lesson, we were talking about economic optimization. And we said economic optimization is a process of making the best of a situation or making effective use of a situation or resources. We said that economics is concerned with coming up with optimal solutions. For example, the manager may want to find output level that will produce a higher profit. And we went on and said that optimization involves maximizing or minimizing some objective functions which may be subjected to one or more constraints. Okay, we went on and talked about an objective function. We said this entails what you want to achieve when you make a decision. And we said if the company wants to increase the total profit, then the objective function is, or the objective is to increase total profit. The company needs to come up with optimal decision that will help in the maximization of the profit. Objective functions are expressed in what? Equations. And optimization involves maximizing or minimizing some objective functions. And differentiation is a process that leads to optimization of solutions. We went on and talked about differentiation. We said differentiation is the instantaneous rate of change of a function at a specific point. It is also called the derivative of a function and is denoted by f open bracket x close bracket or dy over dx. We said that this means finding the change in y for a change in x when the change in x approaches 0. That is differentiation. If we consider this profit equation, which is profit is equal to 2x plus 2y squared minus x squared plus 3y, we are saying that what will be the change in x if there is a change in y? And what will be the change in y if there is a change in x? And we said that differentiation can well be understood if we understood the rules of differentiation. There are many rules of differentiation, but our main focus will be on number 1, constant rule, number 2, power rule, number 3, sum rule, number 4, difference rule, and number last, product rule. We started by talking about constant rule. And we said that this rule states that the derivative of any prime number, any number without a variable, is 0. For example, y is equal to 6. If we differentiate y, we are going to find that it is 0 because y is equal to 6 and the 6 has got no variable. It is a prime number. Okay. In today's lesson, I want us to talk about other rules of differentiation, which include power rule. Okay. Let's talk about power rule in the power rule function. Okay. This rule assumes that any function with powers, for example, 10x to the power 7, that is a function that we have, 10x to the power 7. The exponent 7 is the exponent of that expression, should be multiplied by the coefficient 10. In that expression, 7 is the exponent, 10 is the coefficient. And that 10 should now be multiplied by the variable x, which is raised to 7 minus 1. So x is raised to the power 7 minus 1. That's a rule that you should understand. Okay. So if we are to differentiate a function above, 10x to the power 7, how is it going to look like if we differentiate it? It will be like follows. It will be as follows. 7 will be multiplied by 10. The exponent 7 will be multiplied by 10, which is a coefficient. And that will give us 70. The 70 will then be multiplied by x to the power 7 minus 1. After you multiply the exponent by the coefficient, the power must be subtracted by 1. That's why we are saying x 7 to the power 7 minus 70 to the power 6. The thing is that exponent 7, when it multiplied with the coefficient 10, it should then give up 1. So it will be 7 minus 1, giving us 70 to x to the power 6. So if we differentiate 10x to the power 7, our answer will be 70x to the power 6. dy over dx will be 70x to the power 6. Okay, let's continue and talk about other law. Let's talk about sum and difference rule. Now, the sum rule and the difference rule is the same. This rule states that the derivative of a sum or the derivative of a difference is equal to the sum or is equal to the difference of the derivative of individual items. Now, this equation will come with different items. So we are going to differentiate each item that is contained in that expression. For example, y is equal to 3x plus 5x to the power 4. So, if we differentiate that one, it will be here. We are going to differentiate the individual items. In this expression, we are going to differentiate the individual items. Now, the individual items that we have there is 3x and 5x to the power 4. So, how do you go about that? It will be like this. dy over dx, 3 plus 20x to the power 3. How has that come up? How has 3x plus 5x to the power 4 reduced to 3x plus 20x to the power 3? Let's understand this. The issue is, in 3x, the item 3x, we know that the power of x is 1. Now, 1 multiplied by 3, remember, 1 is a what? The power of the variable x. So we are going to multiply 1 by 3, and it's going to give us 3. X, which is powered by 1, will be x minus 1. Remember, when we multiply that 1 by 3, then that variable should give up 1. Now remember that x is just 1. So if we say x to the power 1 minus 1, it is giving us 0. That's why at the end of the day, the x will die because it is to the power 0. Any number to the power 0 is 0, it dies. And that means that we just remain with 3. So that's where you are seeing the 3 coming from in that expression. Okay, let's continue. In our item 5x to the power 4, the exponent 4 will be multiplied by 5, our coefficient. And that will give us a 20. If we multiply the power 4, which is the exponent of x, by the coefficient, which is 5, we are getting 20. Now, the 20 will now be multiplied by x. Now that x will be less to the power 4 minus 1. Remember, x is to the power 4. But after we multiply the exponent 4 with a coefficient 5, then that exponent should drop by 1. So it will be, the 20 will be multiplied by 4x to the power 4 minus 1, which is going to give us 20x to the power 3. How has it reduced to 20x to the power 3? After we multiply 4 by 5, it is giving us 20. Remember, our x was what? 4. But every time you multiply the coefficient by exponent, then the exponent must give up 1. That's why we are saying 4 minus 1. And our variable x is now powered to 3. Because we have reduced 4 by 1 because it was multiplied. The coefficient was multiplied by what? Exponent. And thus x giving up 1 and remain 3. So doing that would have differentiated that expression. Thank you very much. Now, we are not going to talk about product rule. We are going to talk about product rule. We are going to encounter product rule when we talk about unconstrained optimization, and we will later on talk about constrained optimization. Now we have begun real managerial economics. We have begun real managerial economics. Understand the rules of differentiation if you are to be safe. Thank you very much. God bless you. Until next time, shalom, shalom.